Good morning. Myself Dr. G. Nandini from Department of Mathematics. Today we are going to see the topic testing of hypothesis. There are many ways to test the hypothesis. Today we are going to discuss one of the major test, chi-square test. The formula for chi-square test is chi-square is equal to summation OI minus EI square by EI. OI is observed frequency and EI is the expected frequency. And the degrees of freedom for this problem is n minus 1. So let us see the properties. The mean of chi-square distribution is equal to the number of degrees of freedom. The mean of chi-square is equal to the number of degrees of freedom. Where we go to the variance, it is equal to twice the degrees of freedom. So the two major property is mean is equal to number of degrees of freedom and variance is equal to twice the degrees of freedom. And the chi-square distribution is varied with degrees of freedom. Then chi-square by 2 is a gamma variate with parameter gamma by 2. One of the next important feature is the standard deviation variance tends to standard normal variate as n tends to infinity. So the standard deviation, this is a very important property of chi-square, that is the standard chi-square variate, it tends to normal as n tends to infinity. This is a very important properties of chi-square distribution. Let us now go to the applications of chi-square test. There are many applications of chi-square test. The four major applications are described here. To test the hypothesis value of the population variance. So it is one of the major applications is to test the hypothesis values of population variance. Next, to test the goodness of fit. The next value is to check the goodness of fit. The next property application is to test the independence of attributes. The final most application is to test the homogeneity of the independent attribute of the population variance. These are the few applications of chi-square test. In the problem, we will use the degrees of freedom. The number of values is the set which may be assigned correctly, attributely. Let us now go to the problem of chi-square distribution. The table below shows the number of aircraft accidents that occurs during the various days in a week. So we have to test whether the accidents are uniformly distributed over the week. So the given data are Monday it is 14, Tuesday it is 18, and accident in Wednesday is 12, and Thursday is 11, and Friday 15, Saturday is 14. So the accidents are given week wise and day wise, and we have to check whether the accidents are uniformly distributed. Uniformly distributed is one of the characteristics of the accident. So we have to use chi-square distribution to find this, check whether it is uniformly distributed. So solution, let us see the solution. Total number of accidents. When you add all the total given in the days, it will get 84. The number of days is 6. So expected frequency. Expected is nothing but mean. So how to calculate expected frequency? The mean we got is 84. 84 divided by how many days in a week? Given in this problem, it is 6. So we get 84 by 6 as 14. So the expected mean in this problem is 14. So now let us see the table value. So we are going to do this table calculation. First column is OI. OI is given in the question. So the data given the question is written in the OI. EI. The next column is EI. EI we have calculated. The expected is 14. Next you have to calculate OI minus EI whole square. To calculate OI minus EI, the first entry 14 minus 14. So 14 minus 14 we will get 0. The second one is 18 minus 14. 18 minus 14 is 4. When you square this you will get 16. The next entry is 12 minus 14. 12 minus 14 is minus 2. When you square it is 4. The next entry is 11 minus 14. 11 minus 14 is 3. When you square it is 9. Similarly, the next entry is 14 minus 1, that is 1. Squaring you will get 1. The next entry is 14 minus 14, which is equal to 0. So the third column we calculate OI minus EI whole square. The next column you calculate OI minus EI whole square divided by EI. The first one 0 by 14. 0 by 14 you will get 0. The next one is 16 by 14. 16 by 14 is 1.14. The next entry is 4 by 14. 4 by 14 is 0.245. The next one is 9 by 14, 0.642. The next entry is 1 by 14, that is 0.071. The next one is 0 by 14, which is equal to 0. Hence, finally adding, we get that summation OI minus EI whole square by EI equal to 2.1425. Okay, now let us go to the problem. Steps procedure. The first step is you have to formulate H naught. H naught is the accidents are uniformly distributed. H1. The accidents are not uniformly distributed. The step 2. Level of significance. If the level of significance is not mentioned, it is 5%. Next step is the test status. That is the formula we calculated in the table. That is chi-square value we calculated as 2.1.